Okay, so number 8, they're telling us that this graph here is a transformation of x squared. Yeah, let's go look again at the what we have in our notes about the basic graphs. There it is. Bigger. Okay. Yeah. So you already know that, huh? Here's x squared right here. It's just the U shape, and notice it always starts. I mean, it's centered at the origin originally before anything's been added or subtracted or multiplied. It's centered at the origin. So in their natural state, all these graphs are centered at the origin, aren't they? Until you start adding, subtracting, multiplying things. So it's a U shape centered at the origin. That's what y equals x squared looks like, called a quadratic. So what's been done? So the normal one would be right here. Let me see. Go through there, go through there, go through there, go through there, like that. So there's y equals x squared. So we're starting with that. That's what we start with. But then they did some stuff to make it right here. The question is, what did they do? What is all the stuff they did? Well, let's try to write it out. Changes made. What were the changes made? Well, they flipped it. I think we can tell right away. They flipped it down, didn't they? They flipped it down. What does that? What do you do to the equation y equals x squared that you start with to make it flip down? What makes it flip down? It's going to be the minus in the front. Are we okay with that? Right? Multiply by a negative in the front, not on x, right? Because it's not an x effector. It's not a sideways effect. You might be thinking, well, oh yeah, I should address a good question. If I was you, I'd probably be thinking, what do you mean, Mr. Hearn? It's not on x. That's right on x. That's just smack right there. No, it's technically not. I know spatially it kind of looks like way. This would be, that would be on x. You see, there'd have to be parentheses. That would let it be right on x. And that's not what we're doing. When it's right here, you might think it's on x, but it's really removed from x's world. What do you mean it's removed? Well, what is x's world? What is x doing? Being raised to the second power, right? That minus is not being raised to the second power. He's not in there as part of the thing being raised to the second power. He's not. That would be this. And by the way, you might look at this and go, Mr. Aaron, that do nothing. If you put that negative in there and you square it, it's just going to be the same as x squared. Right. Good point. You're right. If you're thinking that that's true. And of course, that shows us that if we grab the U-shaped graph and you flip it sideways, what happens? Nothing happens, right? Do you see? I love this is where what I enjoy about math is it follows logic perfectly, which I enjoy. If you took that red graph and you flipped it sideways, clearly, visually, graphically, nothing would happen. It would look exactly the same. And the equation bears that exact truth out. If you put a negative right on x is being squared, and square it, it goes away. Nothing happens to the equation, nothing happens to the graph. A sideways flip does nothing, equation or graph, of course. But that's not what we're talking about. That's not what was done to ours. Ours was flipped down, and so that means the minus is in the front. Negative in the front. Okay, which is different than being right on x. Okay, so let's keep going now. Okay, now let's keep going with step 2. because that's not all that was done. If you just flipped it down, you'd be like this, right? But that's not all they did. What else did they do after they flipped it down? They moved it. Right 1. What's going to move it right 1? Remember? X minus 1. Opposite. X is always the opposite. This makes it go right 1. There we go. Right 1. The negative 1 is actually right 1, isn't it? And it's in X's world, inside X's world, right? So it has an X effect. It's in the parentheses with X. It's in the little world that's being second powered. It's in X's little world. It has the opposite effect. Minus 1 is actually right 1. Finally, last step. Let's wrap this thing up. We are going to go down 1. Or move, I should say move. Not just flipped, huh? Oh boy, I don't know why my pen's going so crazy today. Hold it still. Move down 1. Right? It's been moved right 1 and down 1. So the new center is right here. Right 1 and down 1. What moves it down 1? You know. So we have all the stuff we had before. Let me do a little more room here. All the stuff we had before, the minus, the x minus 1 squared, and then finally minus 1. This right here is going to have the down 1 effect. So there's our equation. Minus x minus 1 squared minus 1. That has the down 1. So do you see them all? Let's go through it. Flipped down. Flip down. Right 1. Down 1. That's what's been done. It's been flipped, move right 1 and down 1. There's everything that's been done to that. So see how powerful these concepts are? See how you can quickly look at this U shape and boom, that quick you can get this complex equation. You just look at this U shape, go, okay, I know the basic U shape is x squared, but this one's been flipped down, negative in the front, right 1, which is actually minus 1 in X's world, inside the parentheses opposite, and then down 1 is minus 1 outside. There's the equation for that graph, boom, that quick. So these are powerful techniques. This is what people do in higher math and science to quickly deal with complex functions and know basically what they're doing and what they look like with these tools very quickly and powerfully.